by evolution to be easy to understand or interact with. Now here's a schematic of an electronic circuit that you might have seen. This is a circuit that takes the square root of an input voltage. It wasn't designed by a human being, it was designed by a piece of software that evolves electronic circuits by John Koza out at Stanford. So the questions that come, I took this schematic to Jerry Sussman, who's an electrical engineering professor at MIT, because I was very excited about this. I said, Jerry, you know, how does this thing work? Explain it to me. And the first thing he said, because he has very good eyesight, he goes, that's a really crappy printout, right? And then the next thing he said after thinking about it for 30 seconds, he goes, where did you get this? I said, well, this guy Koza out at Stanford evolved it. And he goes, but I'm really excited. Could you explain to me how it works? Because if I could understand how these evolved electronic circuits work, then that might help me reverse engineer evolved genetic circuits, right? And he goes, you know, that's a really stupid thing to ask me to do. You're asking me to waste my time. And I said, what do you mean? He's like, well, this thing hasn't been designed for it to be easy for me to understand. So why would you ask me to try and figure it out and explain it to you? So what if nature is like that? What if the evolved genetic systems that we're trying to reverse engineer are like it? Maybe we could design and build new genomes that have different low-level architecture that support greater reuse and understandability. So if you take this sequence here that has these overlapping elements, let's just make a new engineered sequence where we take 3 and we put it over here. We take the control sequence for 3, we put it here. We make some edits to 2.8 so it has nothing to do with 3 anymore. We add some new sequences of DNA in the middle to insulate and separate the functions out and add control hooks and so on. And so we did that. And so here's the